Hello everyone and welcome back to my YouTube channel. I hope that you are doing well. So here I am with our new chapter of class 10 triangles. Okay, and before this I have already made videos on all the theorems of the triangle which are very important like BPT or also known as Thales theorem, theorems related to area of similar triangles, and Pythagoras theorems. Okay, so these three theorems I have already explained. The link is provided in the description box. If you have not seen them yet, you can watch. And the problems mainly which are asked in SSLC exam has also been discussed. The link again is provided in the description box. So why this video then? So in this video I will be explaining this chapter in brief. Okay, in detail I will be explaining this chapter. Okay, and we'll cover all the exercises from this chapter. Okay, since most of the students get confused mainly in the proof questions. Okay, so I will try to make it easier for you. Okay, so this is our first video in that direction, and if you find this video useful, okay, after watching it, kindly do like it, share it, and don't forget to subscribe the channel. Okay, so let us start triangles. So you all are aware that before moving to triangles, let us go to some basics. Okay, uh, you are aware that just a minute. Yeah, I hope you are aware of topic known as congruent. Okay, congruent and similar. Are you aware of congruent figures? You might have studied this in class 9. Okay, see, the congruent figures are those with same shape and size. Both their size and shape are equal. Okay, for example, you can just look at it. Here there is a rectangle. Okay, again there is again one rectangle. Both of them are equal in shape as well as size. You can see it again. If you can look at these triangles, both of them are congruent. So the figure with same shape, okay, the shape refers to, like here this is rectangle, so rectangular shape, and here it is triangle, so triangular shape. And size refers to their like length, breadth. Again here length and breadth, they are equal. And if you take here, it will be A, B and C, the three sides. Okay, A, B and C. Okay, so the shape and size are equal, then we can say the figure is congruent. Okay, if I name this triangle as ABC and this as PQR, so we can write triangle AB, sorry, ABC is congruent to triangle PQR. Okay, so this is the symbol of congruent. Remember this. This is the symbol of congruent. Now our topic is about similarity. Okay, similar. So what do you mean by similar? Okay, similar, again, shape and size. A figure with same shape but different size. That is the difference between congruent and similar figure. Here the shape again will be same but size will be different. Okay, for example, you can look at here. Okay, both of them are what? Triangle, right? But compared to the second triangle, first one is little smaller. So such figure are called as what? Similar figures. Okay, same shape but different size. One more example, you can see it here. What is this? A trapezium. Okay, A, B, C, D and L, M, N, O. So both of them are trapezium and they are similar to each other. Got it? So I hope you have understood what is this similar and congruent, and also I think you can now already discuss the you can distinguish between congruent and a similar figure. Now how to notate this ABC, and if this is PQR, if they are similar, we we denote the similar by the symbol this one. Okay, PQR. This is the sign of symbol of similar. Okay, ABC is similar to triangle PQR. Okay, so I hope it's clear. Now coming further, when can we say two any two polygons? Let me take triangle, since the chapter is mainly related to triangle. I will be taking triangle itself. Okay, if this is a triangle, and let me take a similar triangle. Okay, so this is the another triangle. So see, when can we say two polygons are similar? When can we say, see, two polygons of same sides are similar if all the corresponding angles are equal. If we take these two triangles, triangle ABC and triangle PQR, okay, how can I say they are similar? So for that we have condition. What is the first condition? That all the corresponding angles are equal. This is the first criteria. Okay, for example, angle A of ABC, okay, and angle P of PQR, they are corresponding to each other. Okay, so angle A is corresponding to P, B is corresponding to Q, and C corresponding to R. Okay, vertex A and P at the top, at the left bottom it is B and Q here, in the right bottom C and R here. So the first criteria is they should be equal. The corresponding angles should be equal. Okay, and the second criteria is all the corresponding sides are in same ratio. They must be in the same ratio. For example, AB, PQ, they are corresponding sides, AB and PQ. Similarly, BC is corresponding to QR and AC is corresponding to PR. Okay, just to represent corresponding sides, I am writing this symbol. Okay, so they must be in the same ratio. Now what does that mean? What do you mean by same ratio? See, it means if I am taking this as 2, this is 3 and this is 4. Okay, now same ratio means this can be either smaller or bigger than a particular time. For example, if I take this as it is 4 times bigger than ABC. Okay, this triangle. So if this is 2, this will be 2 into 4, 8. Okay, now again this will also multiply with 4. So 3 4s are 12. Now again this 4 4s are 16. It means what? The corresponding sides, now they are in same ratio. Okay, what is the ratio? It is 2 by 8, which is equal to 1 by 4. So ratio is 1 by 4. Okay, it means what? This is 4 times smaller than this one, or you can say this is 4 times bigger than this one. That is called as the ratio. I hope it is clear. So we represent it like this: AB and by PQ, corresponding sides. It should be equal to BC by QR, and that should be equal to AC by PR. Okay, if these conditions are satisfied, we can say the corresponding the given figures are similar. Okay, remember this. So I hope you have understood about similarity. Now let us see some of the example to understand it in a better way. Okay, then we'll solve the first exercise today. So look at this example to understand the topic clearly. You can see here I have taken two polygons, okay, of side. How many sides are there? 4. What can you call this? It is a quadrilateral, okay, but it's looking like rhombus. Okay, just imagine it is a quadrilateral, okay, of different size and shape. Shape is similar, right? So when can you say ABCD is similar to PQRS? Only when their corresponding sides are equal. Okay, sorry, corresponding angles are equal. So if you look at A, what is it? P. Okay, you cannot say S is corresponding to A. Why? Because the angle A is 105 and here it is angle P which is 105. So the corresponding angles must be equal. P, Q. Okay, sorry, A, P. What about B 100? Here Q. C 70. Here it is R 70. D 85. Here S 85. So we can say PQRS is congruent. Is it congruent? No, it is similar to this polygon ABCD. Okay, the first condition is met, that is corresponding angles are equal. What about corresponding sides? If you take AB, here it will come PQ, correct? Now what about this one? BC, it is QR. If you look at the values, 2.1, here it is 4.2. So it is double of this. 2.3, here it is 4.6, again double. 4.8, 2.4. So 2 and here 2. The gap is of, this is half of the given this number 2 figure. If this is figure 1, this is half of figure 2, or we can say number 2 figure is 2 times bigger than the first one. So both the corresponding angle as well as corresponding sides, angles are unequal and corresponding sides are in same ratio, then we can say these two figures are similar to each other. Understood? Yes. Now looking at one more example. Okay, now look at this. Look at this example. If you see the first figure, okay, is a rectangle and the figure 2 is a parallelogram. Okay, can you say are they similar to each other? So to check that, we have two conditions. What? Corresponding angles must be equal and corresponding sides should be in the same ratio. So if you look at this side, it is equal to this. Both of them are 2. Here it is 3. This is 2, 2, 3, 3. So corresponding sides are equal. Okay, means they can also be in the same ratio. Okay, but what about angles? Are they equal? No. See here, this is a rectangle, so angle between these two sides will be how much? 90. But here, this is more than 90, right? So the angles are not equal. So we'll call this as, yes, we cannot call them as similar figure. Neither they will be called as what? Congruent. Why? Because the angles are not same. Even the shape is not same. So even this will not be called as congruent also. These figures are neither congruent nor similar. Okay, so I hope you have understood the difference between similar and congruent. Okay, so now let us solve the first exercise. Here is your first question. So this is the first exercise, okay, of your triangle chapter, and this is based on whatever we have discussed till now. Okay, so fill in the blanks, and they have also given the options. All circles are, okay, if you take all the circles, this is another circle, this is another, okay, or it can be of same shape, but we don't know whether they have given same size or not. So we can say all the circles are, yes, they are similar. Okay, they are not congruent. Congruent means same. So we cannot say they are of same size and shape every time. Correct? They can be of same shape but not of same size every time. So such figures are called as what? Similar. So all these circles are similar. Okay. Now coming to second, all these squares are, again, they are also similar. Okay. Now, all dash triangles are similar. Dash triangles are similar. So when the all sides are equal of a triangle, only then we can say they are similar. Okay. Okay, this is 2, 2, 2. Again, if this is 4, 4, 4. Only then we can say they are similar. Okay, same shape but different size. It cannot be for isosceles, because if I take isosceles means what? Only two sides are equal, any two. If I am taking this and this are equal, this is 2, this is 2, this is 4. And now if I take another one like this, here these two are equal, 4, 5, and this is 5. So can we call them as similar? No, they cannot be called as similar. Got it? Only the equilateral triangles are similar. Okay, not isosceles. Question number 4. Two polygons of same number of sides are similar if corresponding angles are, yes, equal, and corresponding sides are proportional, that is in the same ratio. I hope you have understood that. Moving to question number 2. Give two examples of pair of similar figures. Pair of similar figures, we can say like circles, then squares. I'm just writing these three, okay, and also equilateral triangle. Any two you can write. These are the examples of similar figures, equilateral triangles. Non-similar figures, a circle and a square. Are they similar? No. One more example you can give as a triangle and a rectangle. Okay, so they are not similar. I hope you have understood. Now moving to next question. Question number 3. What does it say? State whether the following quadrilaterals are similar or not. So are they similar? Can you call them similar? No, they are not similar. Why? Their corresponding angles are not equal. This is 90, but this is not 90. Even though their corresponding sides are in same ratio, their corresponding angles are not equal. Hence, they are not similar. That's all. So this type of question you may expect for 1 marks, or in MCQ they may ask. Okay, so I hope you have understood this. If yes, kindly do like the video, okay, and also don't forget to share it. And in the next class we will see what is BPT and its converse. I'm not going to prove it because I've already done that. I'll just give the basics. Why? To solve this exercise problem. Okay, to solve the second exercise problem, you should be aware of BPT and its converse, and how to solve these problems we are going to discuss it in the next video. Okay, so subscribe the channel to get the notification. You can also join the Telegram channel. The link is provided in the description box to get updates of my videos as well as the important PDFs for your exam. Okay, so thank you for watching. We'll meet again with a new video. Okay, so till then, take care. Bye. Have a great time.